This is lesson 5.6.1 for Algebra 2. It's on logarithmic functions, which can seem like a very intimidating task, and it looks very confusing. Logarithm is to help us solve for unknown exponents. So I'd like to start with the definition of logarithm, then we'll kind of backtrack. Again, the purpose of a logarithm is to help solve for an exponent, especially ugly ones, because other ones we can typically do mentally. A common logarithm is log base 10, and 10 is so common that they actually don't write it. They just write log. If there's nothing written right here, you can assume it's a 10. It's similar to if you see an x, they're not going to write 1x, it's just assumed that this 1 exists here. Or with a square root, they don't write the 2 on the root, it's so common that it's assumed. So these are the preferred method of writing, just like the log form is here. And then base, as a reminder, if you had the power 6 to the 8th power, 6 is the base. When we rewrite exponents in logarithm form, this will make a little bit more sense. So again, this is kind of nonsensical right now. These are just some definitions so you're familiar with them, but we'll look at examples in a moment. The definition of a logarithm says that if a and b are more than 0, then log base b of a equals x. The way you read this is log base b of a equals x. It's equivalent to a equals b to the power of x. This is called log form because there's a log in the expression, and this is called exponent form. There's really one thing that I remember as I work through this. If I can remember one piece, then most of the others will typically fall into place. What I remember is b is the base, it's on the bottom. So you'll notice that b shows up, it's on the bottom here, it's the base of the exponent, and when we move down here, it's on the bottom. When it's on the bottom, you divide by it. So in order to find the solutions of missing powers, what we're going to do is take log base b of a, and you take the top, or what's written bigger, and put it up top. That's how I remember it. So log of a goes on top because it's bigger. B is on the bottom, it goes on the bottom. So this kind of looks wild right now. Let's look at a few examples so you get what's happening. So we have two forms. We have log form, log b base bottom of a equals x, which can be mixed up into b to the power of x equals a. Right now, what we have is 10 as our base and 0.0001. So when we rewrite this, it's going to become log base 10 of 0.0001 equals x. Because this is the common log, you can literally type into your calculator log 0.0001 and hit enter, and it'll give you the solution, which is -4. That means 10 to the -4th power will give you this. But what I said in class is you don't need to memorize 2 sets of rules. The same logarithm division system will work. So you can take log of 0.0001, divide by log of 10. You put this on top, this on bottom. Hit enter and you'll get -4 also. So this one, if we rearrange, log base 10 of 21 equals x. You could type in log 21 and hit enter, and you'll get 1.32 for x. Or, to be consistent, you can do log 21 divided by log 10. And the last one is a little bit weird. You have to divide by 3 first. So you get 10 to the x equals 29. Then you go log base 10 of 29 equals x. Log 29 divided by log 10. X equals 1.46. So that means 3 times 10 to the 1.46 power equals 87.